So my name is Rishi, and today I am going to explain the algorithm to find distance between closest pair of points. So our goal is if we are given a set S of 2D points containing x and y coordinate, then we have to find 2 points between which the distance is the smallest. So here we are going to use the Euclidean distance. We can use any definition of distance, but for this case we are using Euclidean distance. First formula you can see here. So we are going to use the divide and conquer approach for the algorithm, which is basically we first divide the problem into sub-problems, then solve the sub-problems recursively, and then combine the sub-problem solution to form an overall solution. So now I'm going to explain you the algorithm. So here is a 2D plane which have many points on it. So first we sort the points according to the x coordinate. Then we find the middlemost element. So let's say this is the middlemost element. So we divide the points into two halves. And now we find the closest pair on each side recursively. So let's say that this is the smallest distance on the left hand side, which we will call DL. And this is the smallest distance on the right hand side, which we will call DR. So it is possible that the closest pair may be formed by points on opposite side of this line. So what we do is we can draw a strip like this, and the distance here will be D. So what is D here? D is the minimum of DL and DR. So the closest pair with one point on each side will lie only in this strip. It cannot lie outside the strip, because if it lies outside, let's say this point is outside, this point is outside, so we have to take distance from the left hand side of the strip. So of course it will definitely be greater than D, because the distance from here is at also D. So our point lies inside. So now we have to find the smallest distance inside the strip. So you may think that the time complexity of finding the smallest distance may be n square, but here's the trick. We don't have to compare every point, distance from every point. We just have to compare distance from 7 other points. Let's say this is the point. So we have to at most choose 7 points to compare. So here's the explanation. I have divided the strip into two parts, such into squares of size d by 2, d by 2, and every square lies either on the right side or on the left side of the middle line. No square lies in between. So let's say, so what is how many points can fit inside one box? The answer is 1. The reason is that what is the farthest distance in this? So it is a diagonal, which is this. So what is the length of the diagonal? It's d by root 2, which is around 0.7 d. So if 2 points lie on diagonal, let's say, so it will be less than d. But we have already searched using our algorithm, and we have found the small distance to be d on the left hand side. So this is a contradiction. So therefore no point can lie, only one point can lie inside this box. So since only one point can lie inside this box, and we don't need to find search behind this beyond distance d. So if a point lies inside this box, we have to search in it, find distances for at most 7 points and compare them. So the time complexity becomes order of n. So let's say after comparing, we get the smallest distance from the step to be delta. Then we just need to find the minimum of delta and d, and that will be our distance between closest pair of points.